In this video we'll be preparing benzyl chloride, a useful synthetic intermediate. A quick word of warning: benzyl chloride is easy to make, but nastier than it seems. It's an alkylating agent and also highly irritating. Avoid all contact. We're going to use zinc chloride as a catalyst in the reaction. You can do the reaction without this, but it requires refluxing and takes longer. Measure out 33 g of anhydrous zinc chloride. We've got ours wrapped up here to avoid absorbing atmospheric moisture as we had a short break between weighing it and doing the reaction. Now measure out 160 ml of concentrated hydrochloric acid. We've got our first 80 ml measured out here. The next step is going to produce some HCl fumes, so be sure to switch on your ventilation at this point. Add the acid to the zinc chloride. Note that the hydration of the anhydrous zinc chloride will produce some heat, and this will cause the mixture to bubble, releasing some HCl gas. Stir to dissolve all the zinc chloride in the solution. We've now got a slightly warm solution of zinc chloride in hydrochloric acid. Set up the 500 ml flask with a magnetic stir bar and pour the solution into this. Get this gently stirring. Now measure out 50 ml of benzyl alcohol. As you pour it, note the oily viscosity of the liquid. Add the benzyl alcohol slowly to the stirred warm acid solution in the flask. As you add the alcohol, you can see a milky color immediately generated in the solution. This due to the immediate formation of benzyl chloride, which is insoluble in the mixture. Gently warm the mixture whilst stirring on a hot plate, up to around 60 degrees C. If we stop stirring just for a second, you can see that pretty quickly we've got a layer of product building up. Keep this warm and stirring for the next 2 hours. An equilibrium is being created. Benzyl alcohol reacts with hydrochloric acid to form benzyl chloride and water. But benzyl chloride reacts with water to form the alcohol again and hydrochloric acid. The zinc chloride helps push the reaction to favor the formation of the chloride, and with the product being soluble, this helps drive the equilibrium. If you're not using zinc chloride, you'll need to reflux, but with the zinc chloride we find that keeping at 50 to 60 degrees the reaction can be done with a stopper lightly in the flask. Here we are 2 hours later. We've got a slightly yellow colored top layer. Chill the mixture down so it's less volatile, then set up the separating funnel and pour it in. The top layer contains our product, so separate off the bottom acid layer carefully and try to get rid of as much of this acid layer as possible. Take care disposing of this aqueous acid mixture as it contains some benzyl chloride. If you can't taste anything properly for a few days after you dispose of it, then don't say we didn't warn you. Here's the layer containing our product in the separating funnel. Now make up a saturated solution of sodium hydrogen carbonate in about 30 ml of water. Add this to the separating funnel in order to neutralize any remaining acid. Swirl well. Then add a little more water if you want the layers to be a bit easier to separate. This time our product is in the milky colored bottom layer. So separate this off into a good storage bottle which can be tightly sealed. The milky color is due to water, but we'll remove this in a minute. There was some white emulsion or perhaps a precipitate in the bottom of the aqueous layer, but we discarded this. So here's our crude product. Let's first remove the water from this. Add a small amount of calcium chloride to the bottle and then close it up again. Swirl occasionally over the next 12 hours and the mixture should clear up to reveal a transparent pale yellow liquid. Here's our crude product. This is impure and still contains some benzyl alcohol, so we'll need to distill it. Distillation of benzyl chloride is something at ChemPlayer that we look forward to even less than making cyanide, liquid bromine, or bromoacetone. Do not attempt this unless you have good equipment and strong ventilation. We're using a 250 ml flask for the distillation. We're also doing an experiment in this run to see if we can remove excess HCl vapors by adding a small amount of sodium bicarbonate to the boiling flask. You'll see later if this worked. We're set up for simple distillation using a thermometer to record the vapor temperature. Because benzyl chloride decomposes at high temperature and because it has a high boiling point, in principle you should use a vacuum to distill. However, we prefer to sacrifice yield for safety, and we're not going to use a vacuum because we want to minimize exposure of our equipment and atmosphere to benzyl chloride. The liquid starts to distill fairly quickly on strong heating, but the vapor takes a while to reach the distillation adapter. We used some aluminium foil to insulate the adapter. And here we go. Distillation commences. The boiling point seems somewhat low at 166 degrees C. This could be due to atmospheric pressure, or because of the small amount of water in the distillate being produced by the sodium bicarbonate decomposition. Without the bicarbonate, the distillate is usually less milky than this. Throughout the distillation you can see some HCl gas being generated. This seems to be due to the high temperature decomposition of the benzyl chloride into polymeric substances, eliminating HCl in the process. The bicarbonate didn't help, so we don't recommend using it. Once about 3/4 of the liquid distilled off, the vapor temperature dropped slightly. We took this as an indication that distillation of our product was complete, so we stopped heating at this point. As you can see, the boiling flask contains a residue of brown solids and a viscous liquid. This is a pain in the ass to clean out, with acetone only removing some of it. Scrubbing using a bottle brush was required. In order to more safely clean the apparatus, make up a strong solution of sodium hydroxide in water. Soak any equipment that has come into contact with the benzyl chloride for at least 30 minutes. When the distillation apparatus is cool, pour this in and get some down the condenser as well. This will help, but cleaning up is still unpleasant. Okay, here's our milky distillate, which mostly contains benzyl chloride and a small amount of water. Due to decomposition, this also contains some dissolved HCl gas, and the distillate fumes strongly in air, as you can see. To remove the water, swirl with anhydrous calcium chloride, and quickly the liquid will become transparent. To remove HCl, we have found that swirling with a small amount of anhydrous sodium carbonate for 10 minutes seems to do the job well. Here's our product, 34 grams of fairly pure benzyl chloride. This is a 56% yield on starting benzyl alcohol, which is not amazing, but it's acceptable given that we were able to perform this with minimal exposure to the toxic product. Do know that if you want to use this in a Grignard type reaction, you will need to remove all traces of water and HCl from it. After shaking with anhydrous sodium carbonate, we're storing over calcium chloride granules to ensure there's no water present. So let's do the ultimate test of purity. Here's some cold dry ether. And here's about 1 ml of the benzyl chloride from the container you just saw. And a few magnesium shavings. And here's a crystal of iodine to help get things started. After just a few minutes we've got some bubbling occurring from the magnesium. And this gets stronger and stronger over time. This looks pretty good to us. Thanks for watching and stay tuned for more reactions.